How do we say good? Hi, Alan.
Want to say hi, Alan? How's the weather in Hawaii? Must be nice. All right, let's do a recall on our acronym, Twiggy. If you were gone and you didn't make anything up, make them up and then ask me all the questions next period. But right now, you don't have the right to. So, F stands for find. W stands for when. What does G stand for?
Given.
The given. And remember, the given is always the rate of. And then E stands for equation. We need an equation to make or to derive anything. Let me zoom in a little bit. All right, Castro, go ahead and read number 1 loud and clear.
A kite is moving horizontally with a speed of 7 meters per second and an altitude of 30 meters. Determine how fast the length of the string is, increasing when the kite is 50 meters from the kite flyer.
All right, so let's go ahead and write out Twiggy on this one. Twiggy. And let's see what all I need. The find is like, what are we actually looking for? So do I see the keyword that's going to replace the word find? Determine, that's going to be our find. Find how fast the length of the string is increasing. So let's start by making our triangle off to the side. Here's my right triangle. And I'm going to say my hypotenuse is always C. And we're flying a kite, right? I should be artistic here. Kite. And you are the kite flyer, who is right here, having a good time. Now, does it matter where the side A and B might go? No? Now, to be consistent, when I think of A, I think of altitude, the height from the ground to the item. I'm going to go ahead and put A right as my height. If that bothers you, swap it. Except all of our work is going to be swapped, and it'll be quite confusing. All right, so then, let's see what information I have. It says, determine how fast a kite, the length of the string is increasing when the kite is 50 meters from the kite flyer. So we know our C is 50 meters. So do we see the word when right here, W?
Yeah.
So we know C is equal to 50 meters. I don't know why it's not in feet, but that's fine. And then our string is increasing. So as you're flying the kite, as it goes further and further out, you have to release the string, right? So that string is our dc over dt. Because C is our hypotenuse, and that is the length of our string. Do I see any given derivative anywhere? Where?
Speed of 7 meters per second.
Okay, speed of 7 meters per second. Now, it doesn't say the word rate of, but the speed is the rate of. So that's going to be our given, the G piece. Now, our kite is moving horizontally. Horizontally is B value. Does everyone see that? B. So we know this one's going to be dB over dt. And that is 7 meters per second.
What is the B?
B is a distance from the ground.
Oh, okay.
And then we know our equation is our Pythagorean. What was that again? A squared plus B squared is C squared. So let's go ahead and write that equation off to the side since we need to take the derivative. And try to write small. Don't write so big like mine. All right. And all of our word problem is taking derivative with respect to x or time. So what is the derivative of a squared? 2a, and we have to always write out dA over dt. If it's not deriving the t, we have to put d that letter over dt. What is the derivative of b squared? 2b, and we have to go ahead and multiply it by dB over dt. And then our next piece we have 2c and dc over dt. So here's the beauty about all of our Pythagorean theorem. What do I have as my coefficient throughout the whole thing? 2. So what I can do is ignore them completely. Gone. So let's plug in what I know right now. So at this point, we know, the altitude was 30, that was given. Did not write that down. Given the hypotenuse in one of the legs, could we figure out the other leg? Anybody remember the Pythagorean triple? 3,
40.
boom, 3, 4, 5.
45.
Let's say you get stuck. Can you use Pythagorean theorem on the side? Yep, but I'm not going to show that part. So let's fill in what I know. A is 30. Plug it in. And dA over dt. So let's kind of think about what's happening. If it is only moving horizontally, there is no vertical movement. Well, movement. And because there's no vertical movement, it means there's no speed to the vertical line. So my vertical line, our speed is 0. So if it's saying it's only moving vertically, that might be the same for the A value or the B value. So we have plus. Do I know what our B value is according to part of my given? 40. What was the rate of B with respect to T? 7. Then I have my C is going to be what number? 50. And then we have dC over dt is what we're looking for. So let's make sure all the variables are already plugged in except what we are looking for. We are finding the speed of the string, and we are looking for the speed of the string in our equation. So are we okay with that? Yes? All right. So I'm going to do some shortcuts on the calculator on this one. Since I know multiplying by 0 doesn't really matter, could I do 40 times 7 and divide it by 50?
Yeah.
So that's going to give us dC over dt is equal to 5.6, and that's going to be in meters per second. And what's going to make sense with this one is, as it's moving horizontally, the string has to be let go a little more at a time. And it makes sense that's getting, it is increasing on me to the positive direction. All right, even though number 2 is essentially the same thing, let me have somebody read. Mason.
A kite is falling vertically with a speed of 5 meters per second and being blown horizontally at 7 meters per second, while it is at an altitude of 30 meters. Determine the speed with which the string is being paid out or taken in when the kite is at 50 meters from the kite wire.
Okay, so let's go ahead and write out Fuigi on the side over here. Again, it's basically the same question, maybe one more information given to us. Okay, what are we determining? Whether the string is getting paid out or pulled in. So we know we're still looking for dC over dt. And did the condition of the triangle change at all? Nope. Let's go ahead and draw the triangle off to the side. So here's my triangle. Here's A, B, and C with the right angle. Draw the person if you want to, but I think I'm good with that. So C was 50. B was it 40? A was 30. What information is given to us with the when?
Speed of, oh no, right?
Uh-huh.
That the kite's 50 meters from the flyer.
Okay, so we know when the kite is still 50 meters from the flyer, so that's going to be still our C. And on the given information, we have something. What is that something that we know about?
Speed of 5 meters per second.
So it is falling vertically. When something is falling vertically, isn't it getting smaller or shorter and shorter? So can we use our negative sign to say it is falling? So we know for this one, let's write out. When something is falling vertically, it's going to affect the A value, so dA over dt. And because of the word falling, we need to go ahead and put a negative, otherwise it's going to add on to it. So we have 5 meters per second. And does our equation change if it's still the right triangle? No. A squared plus B squared is equal to C squared. So let's go ahead and write everything out. Let's write out the Pythagorean. I kind of don't want to, but I should for teaching purpose. Since we did derive this on the first try, are you guys okay if I write all of that except the 2 that's going to be canceled out? Yeah, let's write it out. We have A times dA over dt plus B times dB. The dB. Did I swap my B and D? Anyone else do that too? I feel you. We think alike. And I don't think it's bad. Okay. D, was it B on this one? Yep. So let's plug in what I know at the moment. What is our A value? 30. What is our dA over dt? -5. What is our B value? 40. What is dB over dt?
0.
Wasn't dB over horizontally also some number? I forgot to write that down, huh? dB, that's my fault.
7.
7. That was also the given. I guess I gave you too much, huh? That's a problem. And then our C value happens to be how many? 50. And then we're looking for dC over dt, so let's leave that alone. For this one, since I had a horizontal and a vertical rate, I had to put all the rates in it, which means there's not 0 unlike the previous problem. All right, so we know that number is, what is that, negative 150? And that number is 280?
130, I think.
130? Are we guessing?
It's
Well, I'm
280.
doing mental math.
It's 282.
And then divided by, oh, together was 130. I was like, what is she talking about? So we're looking at 2.6. So we have dC over dt is going to be 2.6 meters per second. So do I need to take in or pay out if it's going to increase the length? It's going to be paid out because it's positive. If I am shortening the string, then it's going to be taken in. Anybody flown a kite before?
Yes.
You guys have?
Like,
Did you? Is it hard? The wind, right?
12 years ago.
Do you ever get pulled along with it? No?
Yeah, it's really hard when there's no wind.
When there's no wind, it just kind of falls on you. It's a sad day. Okay.
Yeah.
All right, let's go on to number 3. And on number 3, I think I just want to do A and B. We shall see. Colin, go ahead and read number 3.
A 13-foot ladder rests against the side of the house. The base of the ladder is 5 feet from the base of the house. It is moving with a velocity of 3 feet per second away from the house.
Okay, the velocity is our speed. I think I might have missed attendance earlier. Was Ethan out?
It was here earlier, but
Earlier before this period?
Yeah, but not in class.
Oh, not in class. Got it. Okay, let's all write out Fuigi. And this we'll use it on part B as well, so we don't have to rewrite it again. Or maybe we need to. All right, so which one is going to allow us to know the find? Maybe we should draw this picture, right? Yeah, let's draw it. What information do I know?
The ladder, the C is 13.
The C is 13 because the ladder is leaning. If it's not leaning, then I don't know why you need a ladder. Can someone say B is how many? 5. Very good. This is also Pythagorean triple. 5. 5. I'm trying. 5. 12. Thank you. If you were guessing, still good job. 5, 12, 13. Luke, did you already have it? Okay. I wasn't listening very well, huh? I'll work on that. All right. So it says, determine how fast the top of the ladder is moving. The top of the ladder is leaning by the A, correct? So that's going to be dA over dt. And then, do we have any information with when? When the base is 5. So let's write out B is equal to 5, although you can say I have the drawing. Do I have any velocity given, the rate of? The velocity is the rate of. Now, that velocity is from the base. So this is dB over dt. Oh, dB over dt. And that's 3 feet per second. What equation are we using for every right triangle? All right. So let's go ahead and write that down on the very top. And actually, instead of writing it, how about I go ahead and write it from everybody except the 2? What's up?
So on 2.6a.
2.6a.
Yeah, like on the first part of it. It would normally be dB, like B like velocity over dt. Is it B because we're doing the Pythagorean theorem?
Yes, because it's a Pythagorean theorem.
So whenever it has to do with,
How about you watch 2.6a and then come with questions?
no, I did.
You did?
Mhm.
Okay. Well, what was it?
I'm just asking if there's ever.
I'm recording, by the way, so. No?
I know.
No?
Whenever there's a triangle involved, it's never gonna be like C for circumference or B for velocity. It's gonna be A, B, or C.
It'll be A, B, or C for all the right triangles. Okay? All right. So what I'm going to repeat again. I'm going to write from this guy right here. Okay? Because I'm sure we can all find the derivative of something squared. So I'm going to write out A dA over dt. Just copy the top portion. B dB over dt. And C dC over dt. And for those of you guys watching the video when absent, I do appreciate that. Big time. All right, let's plug in some parts. What is my A? 12. Do I have any information about dA over dt? No, and it shouldn't, because that is what we are looking for. So we have dA over dt. What information do I have on B? 5. What about the rate of the B value? 3. And our C? 13. Now the ladder. When you're on a ladder, whether it's leaning or not, should the ladder increase at all? No, it shouldn't. So that means the speed of the ladder will always be 0. Can someone open that door in case it's a pass for me? So we know this guy is going to go away. So what I see at this point is dA over dt. When I subtract it on both sides, we get negative 15 over 12. And our anticipation, I didn't do the anticipation a while ago, is negative. And let's go ahead and see what this decimal value is, because the word problem will be open calculator on this one. 1.25 feet per second. Thank you. You guys have any idea on why it's negative? Because I'm going to show you with the picture. Look at the picture. It says the house is moving with a velocity of 3 feet per second. So what's happening is this. The ladder is getting further away from the house. If the ladder is getting further away from the house, does it make sense to keep the ladder of 13 meters or feet? It has to go down. So it has to go down. And because it has to go down, our speed of that specific spot has to be negative. Okay? Do you have a pass?
I don't.
You don't have this thing? Okay. All right, let's go on to part B. For part B, Edith, go ahead and read. That's the last thing we're going to do.
Determine the rate at which the area under the ladder is changing.
Okay, the only thing we need is the area of a triangle. So let's see if y'all remember the area of the triangle. To find the area, I'll start with the first one. Half base times height. Now for us, it's base times. I'll write base times height and then change it. Let's write out for us, area is 1/2. Whether I multiply A times B or B times A, those are the base and the height, right? And I want to go alphabetically, just because I feel like it, AB. If you want to write BA, we'll get the exact same answer. So let's go ahead and find the derivative with respect to T. So the first one is going to be derivative of 1A is 1. And I don't want to write the 1 anymore because that's understood. So here we have a product rule. So derivative of half of A is how many? 1/2 dA over dt. And then we need to keep the second one. What sign separated the product rule? Plus. And then do I keep or change the first one on this one? Keep. And when I change my second one, the derivative of 1b is 1. And then we have to do dB over dt. Look what I did again. dB over dt. That's amazing. So we have, and again, I'm not writing at the 1 because it's understood. Can we now plug in what I know?
Yeah.
Yep. Let's plug it in. We are looking for, I'm going to actually go down here and use this room. dA over dt is equal to, the 1/2 is a number, so I'm going to leave that alone. What was our dA over dt that we found previously?
Negative 1.5.
Negative 1.25. And then what was the value of b from the picture? 5. And then we have plus, half remains. What value is our a? 12. What was our dB over dt? 3. And when we type all that in, that's going to give us 14.875. And this is area. For area, should I write feet? Feet squared, feet cubed? Feet squared. And done. Part C, Xavier, go ahead and read that number. Not the number, the words.
Find the rate at which the angle between the ladder and the ground is changed.
All right. So the rate at which the angle between the ladder and the ground. So I'm going to go ahead and draw this image one more time. So here's my image. And here's my ground, which is 5. D is 5. And our ladder C is 13. And how high was the altitude? How many? 12? Yeah? So we have a right angle. So the ladder to the ground is this theta right here. Because the ladder is the hypotenuse. The ground is our B value. So from there, we have find, we're looking for d theta over dt. It is a degree measure we're looking at. So let's kind of predict. As the ladder gets closer and closer and closer to the ground, what's going to happen to the theta? Is it going to increase or decrease? It's going to get smaller. So we know this one has to be a negative number. So our anticipation is that d theta over dt has to be negative. That's going to be one way we're going to check. Okay? And then the equation. So you have many equations from your trig unit. We can either use sine, cosine, or tangent. Which one is easy to find the derivative? Sine. Now, could you use cosine if you wanted? Yes, you can. Tangent, you can, but that will make your life miserable. So let's go ahead and write out sine theta is equal to my opposite. What letter's on the opposite of theta? 12. So A over, what's on the hypotenuse? The C. You could write 13 and 12, not a problem. So let's go ahead and write that off to the side. So when your equation is not given and you're like, I have no idea, most likely it's going to be our proportion. Okay? So let's go ahead and write out. Find the derivative with respect to t. What is our derivative of sine? Cosine. And then we have our product, or not product, quotient rule. So we have c squared. The quotient rule states, derive the top. What is the derivative of 1a? 1. And I know we have to write dA over dt. Notice I did not write the 1 because it's understood. If it bothers you, write the 1. Okay? And then we keep the bottom. And what sign is separating versus the product rule? Minus. And then we keep the first one, a. What is the derivative of 1c? 1. And we have to write dc over dt. And then at this point, let's plug in all the values that we possibly know. Cosine theta means what is the ratio? So the ratio of our cosine is adjacent over hypotenuse. Do we see my adjacent is 5? Yeah? Let me see if I skip the step. I might have. Oh, did y'all realize I forgot to write d theta over dt on this one? That's my bad. Because when you're deriving anything with a non-t, we had to write d whatever over dt. And that part completely slipped out of my mind. So we know at this point, cosine theta is the ratio. Our ratio is 3 over or 5 over 13. And d theta over dt is what we are looking for, so leave that alone. What was dA over dt from this problem at the beginning that we found? Negative 1 point something. 2.5. Very well. This was on part A, if you did not get caught up. And then the next piece was our C. What is our C value? 13. Minus, what is our A value? 12. And then we also found dB over dt. What was our dB over dt that we found? And actually, did we even find the dB over dt? Or dc over dt, I mean? If the ladder is leaning, can the ladder ever grow? So if the ladder is constant, it's not going to grow. So that means we have 0. So we have all divided by c squared, and our c squared happens to be 13 squared. Yeah, it'll be 169, but I'm going to go ahead and type all this on the calculator. So let's do something. We're going to divide by all this guy. So divided by 5 over 13. And the good news is, for the word problems, it's going to be a calculator portion. So if you would, if you have your calculator, if not, you can look up at the screen. Just watch and see if I make a mistake anywhere, because most likely I might type in something silly. So I'm going with the top one. Negative 1.25. I see 13. I know the 12 and the 0 we don't need, but I'm going to leave it for teaching purpose. Wasn't that fraction over another fraction? What's that? Should I do that again? Will that work out on this one? No, it's this whole fraction over this one. So let's do it again. Oh well. But what else could I have done? Parentheses? Yeah, we can. But since we have that alpha y equals function, let's use it. I know. It's like, don't mess up. 13 squared. On the bottom, I'll do alpha y equals again. All right. I want you guys to check this and make sure I have typed in everything correctly possibly. Is that good? All right. So our anticipation was a negative answer. So we know our d theta over dt should be decreasing, meaning we have negative 0.25, and that was in radians per second. Because theta is radian. If you want to say degree per second, I'll take it. All right. Now let's go on to number 5. And I'm going to record this piece and try to merge it together with the first video for the convenience of you guys. So let's go on to number 5. All right, Cody, let's read number 5, please.
A man whose height is 6 feet walks from under a lamppost at the rate of 3 miles per hour. At what rate is the extremity of the shadow traveling, supposing the height of the light to be 10 feet above the ground?
So he is next to what? A lamppost. How you draw this doesn't matter. You don't have to be creative like mine. It's not that pretty though. And he is standing away from it because he is walking away. And if you would, try to make a right triangle with his head. Not with his head, to the corner. And there's our right angle at the lamppost. If it's going through his face, that's okay. Maybe it's the eyesight. Okay, let's go ahead and write out Fuigi off to the side. I think I have room on the bottom. Let's write out Fuigi. And quick reminder, in case it's been a while. How tall is the person?
6 foot.
6 foot. Could I also say hopefully he is perpendicular to the ground unless he's leaning? Okay. And then what other information do I know? The lamppost is how many? 10 feet? Very well. So what piece are we finding? At what rate is the extremity of the shadow traveling? And you're like, what in the world does that mean? What this basically means, how many triangles do I have embedded in that figure? I have 1 and I have 2, okay? So let's go ahead and name this real quick. I am going to say this whole thing is going to be my t as in total distance. And then how you name the next one doesn't really matter, but the way I see it is he is first going to be here, and then later he'll end up somewhere over here. So I see the F as in first, L as in later. If you want to use A, B, C, that's okay as well. Okay? So then from there, it says he walks from under a lamppost. Now, which place has he gone already? Has he gone the F unit or L unit? The F unit. So this right here is going to be the given rate. So our given rate on this one is dF over dt, because that's the place he's already gone under. And that value is 3 miles per hour. Is M alone miles? Should it be MI? Let's do mi. So then the extremity is what we are looking for. Extremity is the largest piece. What is the largest piece? The F, the L, or the T? The T. So we have dt over dt. Oh God, dt over dt. D capital T over D lower t. So let's go ahead and define this. It is a distance from the light to the tip. And the tip means the corner, all the way to the corner. And didn't we already say wind piece already? The wind was, he was how tall? The person was 6 feet and the lamppost was 10 foot. Now the equation is a problem. Going back to geometry, when I had two figures, you were told to separate them. You don't have to if you don't need to. So I'm going to try without it. I'm going to do the vertical piece to the base piece. So 10 over t. Let's all write out 10 over t. Oh, I said over t and I wrote t on the side. Should be divided by. And so if I do 10 over t, 10 over t. Yeah, I'm having a moment. It's like almost our Friday, right? Is equal to. So if this is 10 over t, how would I relate that with a small triangle? 6 over L. That's it. And if we look at this, you might go, well, why do we have two different variables? I can actually use this to where I could have a different variable than L. So let's see what I have. And I want you guys to highlight something. We have dt and we have df. And I want to make everybody in terms of t and f. Do you see that L is in the way? So let's rewrite this. And I'm going to rewrite this with the following. I like the 10 over t, no problem. I like the 6 on the top. But for the L, I could rewrite the L by saying t minus f. Then that way, according to our the f and the g, we have in terms of t and f. Is everyone good with that? I had to convert it because it has to be consistent to our rate. Okay? And then from there, let's go ahead and cross multiply. Y'all remember cross multiplying from like, I don't know, junior high? Has it been a while? All right. So when I cross multiply, I'm going to write out this piece first. So I have 10t minus 10f is equal to 6t. Is everyone good with how I cross multiplied here? Okay. So now let's go ahead and find the derivative. So we have d over dt, and be really careful, you have a capital T and a lowercase t. So what is our, should we have moved this over to make it easier? Look what I did. I'm such an idiot. Could I have moved the 6 over here to make it easier? Could we put on this 1/4t over 10f? And then find the derivative to make it simpler than deriving at two different locations. So get rid of this. It'll work out, but you know, if there's an easier way, why not use it? All right, what is the derivative of 4t? 4, so we have dt over df. And then on the next one, what's the derivative of 10f? 10, and that's df over dt. And let's see if all the parts are given to us. We are solving for dt over dt, as I wrote the f on there that I'm going to fix. Which variables are given to us that we can plug in? So we know this piece is what number? The 3. Let's go ahead and plug it in. So we have dt over little t, 10 times 3. Are we okay if I just divide it by 4 since we have that 4 being multiplied at the beginning? Okay. So let's do our mental math. Or y'all can type it in if you want. 10 over 3 or 10 times 3 is going to give us 30 divided by 4. 7.5. Wow. And that's miles per hour. Boom. Good job.